Earth scientists draw together math, chemistry, physics, and to some extent biology in fields such as geology, geophysics, and environmental science to solve some of the biggest puzzles about the inner and outer workings of our planet. Earth scientists also address some of the biggest challenges faced by society, including natural hazards, natural resources, climate change, land development, and land use.
Coastal hydrology, because it relates to the place and to people, I can really involve my students, both from my classes and those who work on research projects, so the undergraduate and graduate students, in real-life problems, solving problems that are currently occurring and might be exacerbated by climate change, to help the communities. And so we have place-based learning, understanding how the coastal springs have been used in the past versus what their status is currently. This also includes service learning, helping communities such as farmers, caretakers of fish ponds, in understanding of all these layers of the hydrological processes, the climate change-induced changes, and also, of course, pollution from humans.
One of the things that I think is really valuable about the class scientific programming is that it teaches you how to solve problems. It's truly, really and truly a problem-solving course. But in a more practical sense, you're going to gain skills and knowledge in scientific programming that you can apply to any sort of programming application. So, it's the world of computer science these days, and the skills that you gain in that class you can utilize in any type of computer science application.
Favorite class I've taken here is Geologic Field Methods, by far. And the reason I like that one so much is because it's sort of the class you take at the end of your degree that sort of combines all the knowledge you've learned, everything from every class, into one sort of holistic experience.
One of the classes that I teach is our Geologic Field Methods course. And in this class, the students are usually seniors, and the goal is to apply the classroom and lab knowledge that they've gained over the previous 3 years out in the field. And so most of the projects involve obviously being out on places on Oahu. We also go to the Mojave Desert for a week so that they get to see rocks and fossils and features that we don't have here in Hawaii.
I feel like what's important is the community, and the community here at the Earth Sciences department is really friendly, and they really want you to succeed, and they really care about what you're interested in. So I guess an advice I'd have is to just stay curious and be passionate about your interests, because there's always going to be a professor that's also going to be interested in that field, and I think they can really help you. I think the connections you make with your peers are really important too. We have a lot of clubs, such as the SOAS Club, the Geology Club, and it's a great place to make some connections with your peers, and you can make some friends, and I think that's just gonna stick with you your entire life.
We're interested in a wide variety of problems, and some of them seem really esoteric because they're remotely occurring down in the earth with maybe less direct societal relevance. And yet, science has a way of finding applications for things that are developed for their own right to begin with. But there's another side of what we're teaching in these classes which is directly applicable to society, such as the resources of the earth that humans need in order to have a society. It involves understanding where those resources exist in the earth, what is controlling the rate at which they are formed, how do we deal with materials once we're done using them and they need to be disposed of. All those things require an understanding of chemistry of materials. And so at a fundamental level, we're teaching chemistry of materials.
UH definitely is top of the line in terms of volcanology. There are a lot of distinguished professors here. Also, there's amazing access to the volcano observatories research and just volcanoes themselves. I mean, it's one of the few places in the world where you can study volcanoes on an active volcano, which, I mean, that sold it for me.
In our educational mission, we are striving to meet a variety of needs, and one of the needs is for local folks to have jobs that will keep them here so they can be productive and have families and stay in Hawaii, to be trained in skills that will allow them to stay. But there are also broader needs of society at large, so our education also needs to prepare people to study things and to have careers that are well outside of Hawaii. And fortunately, geology is pretty universal on our planet, such that what is happening here is in the soil is likely to also be relevant to soils in other parts of the world.
Well, yeah, it's a beautiful place, and if you come to Hawaii and geology and geophysics and, well, earth science is your passion, you can be studying your passion in a place really like no other.
The campus is an incredibly beautiful place to study. You're surrounded here by beautiful Manoa Valley, but also an incredible diversity of really top scholars. And in EarthSciences, you have an incredible environment where you experience these processes as they happen here on an ocean island.
Manoa in general, so far my experience with the SOEST department specifically has been even they're a little small, so you get that one-on-one contact with professors and other students who are all interested in the same sort of things you are, as well as just the wide range of opportunities. Hawaii's mainly, volcanology, but that's not the only thing here. They have people and research projects going on all over the world and nationally ranked, even globally ranked for research grants and stuff. And it's you just have that opportunity to experience all sorts, and then still being somewhere where there's specific focuses that they're top of their field.
Our students get to work with faculty who are both top researchers in their field, as well as incredibly dedicated instructors who care about the success of the students. And when they graduate, our students enter a variety of fields that address environmental and economic challenges encountered both here in Hawaii as well as elsewhere throughout the country.
When I think of UH, I think of it on a number of levels. First off, it's just an incredible place, and I feel immensely lucky to live here. But in a scientific context, so the science that we do as earth scientists, I think we are in the middle of it at all times, and I think that's really meaningful to have that tangible aspect. And then there's a level of it that, there's more earth sciences going on at UH than probably anywhere else in the world. And it's a really exciting place to be, to see state-of-the-art science across a huge range of disciplines, and it's motivating just to be a part of that.
And education in earth sciences, and specifically then within the field that I'm working on, I feel like we are really providing those tools for the next generation to be better stewards for land, take care of our absolutely primary resource for our life, which is water, and of course the ecosystem that surrounds us. And having specialists that had that hands-on experience is absolutely essential in this field, people that understand how to relate to the land and its culture and its history, so we can help the next generation gaining that knowledge and those skills.